All right, Algebra 1 students, thank you for hopping into today's lesson, Lesson 9, our first lesson of the second quarter. Let's go ahead and rock it. Here we have Lesson 9. We have checking and finding solutions in two variables. Okay, what we just came off of in Lessons 1 through 8 was a focus on one variable in most of those problems, not all, but most. That variable was x. Now we're going to take a look at finding solutions in just many things that have to do with the equations in two variable. Okay, it's going to be our focus. We have here first, it says, in this chapter, we want to take a look at the connection between algebra and geometry. This connection is made by the graphing of equations. It says we will start with the easiest of all equations, which is the linear equation. Okay, linear equations in two variables. There's many forms of this. The most popular form that you guys have already been exposed to is y equals mx plus b. That's where our variables are y and x. We also have variables of m and b, which these represent something specific in that equation on a graph. We even have another example of a linear equation that you might see is ax plus by equals c. Again, we see those variables x and y, and that's where a, b, and c would be integer values there. Okay, again, this is the one that we're probably familiar with at the moment and we like staying comfortable with and using. We can always make equations look like this, y equals mx plus b. It just takes a little bit of work to get there in order to use it in ways that are convenient to us. It says that there are many things that we want to do with linear equations, but one of the most important things to do is to find solutions. It says, in this case, since the equation has two variables, an x and a y, the solution must have both an x and a y part. Okay, here's an example of a situation where you might be asked that. Here, an example A. It says, is the point negative 1, 3 a solution to y equals 2x plus 4? Well, we've done this in, I believe it was lesson 1 a few weeks ago. In that case, we were just given something like, is x equals 2 a solution? And we plugged it in for x. Well, the only difference now, okay, is that we have this point, right? We know that this point, this is the x variable, this is the y variable, that's somewhere on a graph. We don't see the graph, but excuse me, but that's where it is. And then we're going to use that in this equation here, this y equals 2x plus 4. So I treat it just like I treated the work in lesson 1. Now, instead of one variable, I have two. So I'm going to go ahead and take this y value out, and I'm going to substitute a 3 in there. And I'm going to take this x value out. I'm going to leave the 2 stays. I'm going to take the x value out that says 2 times x, and I'm going to put this x value here of negative 1 in. So now I have 2 times negative 1 plus 4. I just essentially need to now summarize and simplify both sides of this equation here and just figure out, is it true, is it false, and then make my decision from there. So the left side is just 3. I'm going to leave it as 3. The right side, I see 2 times negative 1, which is negative 2, and I bring down the plus 4, and negative 2 plus 4 is 2, and the other side of the equation is 3, and I get this, 3 equals 2. Well, again, what was I asked? I was asked, is negative 1, 3 a solution to this? Since this is not true, we say no. No, negative 1, 3 is not a solution to y equals 2x plus 4. Okay, so a solution means if I were to graph this, that point, this would be on that line, and it's not. It's not a solution. It doesn't fit because we get a statement that is not true. Okay, next, same equation. It wants to know, in B, it wants to know, is 0, 4, is the point 0, 4 a solution? Well, again, we know this is x and this is y. Let's go ahead and plug them in and find out. So I get that y is 4, so I get 4 equals 2. And then I have that x. Well, that x is 0 in this point it's asking about, plus 4. Let's simplify here. I get 4 on the left. 2 times 0 is 0. Bring down the plus 4. I get 4 equals 4. 4 equals 4. That is a true statement. 4 does equal 4. So we would say yes, 0, 4. Whoops, those are parentheses there. Is a solution to y equals 2x plus 4. Pretty straightforward. I'm not going to spend much more time on that. It's essentially, instead of one variable 2, you just need to make sure really that the x variable is having the x value put into it, and the y variable is having the y value put into it there. It says, even though finding out whether or not a given ordered pair is a solution, it is far more important to be able to determine the solution. Sorry, total brain fart. To the equation when we are only given the equation itself. Okay, so now we are going to generate the solution. We're not checking to see if a solution is right. We're checking to see what the solution is. Okay, so here we're being asked, it says, find the ordered pair solutions for the given equation for the given values of x or y. So here it looks like is our equation. X equals 4y plus 0. And the first thing we're being asked about is it's saying, well, what's the solution when x equals -4, right? So imagine this, okay? I'm going to see if I can give some more room here. I know in this ordered pair that I have an x and a y, and it's telling me here in this first one, well, we know the x is going to be -4, and it's essentially saying, well, what is y? What should go right there? So we're going to find that out by plugging in -4 for x. So I'm going to copy this equation down, but in for x, I'm going to substitute in this -4 that it's telling us. So I have -4 plus 4y equals 0. And now I just need to figure out what y is. Well, that's just isolating y. It's getting y by itself. So in order to do that, right, I just move everything across the equation until y is isolated. The inverse of -4 is +4. I do that on both sides. I get 4y. I'm bringing this down. Equals 0 plus 4 is 4. To get rid of this 4, I divide. And I get y equals 1. So the solution there would be, from this point, -4 comma 1. That is the point. That is a solution to that equation. We were given the -4, and we found the 1. We were given the x, we found the y. The next thing it's asking about here is, well, what about when x is 0? Okay, it's saying when x is 0, what's y? So again, just visually, it's telling us, well, we know x is 0, and, well, what's this? What's y? So we need to go to that same equation, plug in a 0 for x, and see if I can find out what y is. So same equation, but I'm going to take x out and put a 0 in. So now I get 0 plus 4y equals 0. Well, to get rid of a 0, sounds kind of goofy. -0 on both sides. Those are gone. This still has 4y. 0 minus 0 is 0. I can still divide by 4 on both sides. I get here 4 divided by 4 is 1. So I get y equals 0 divided by 4 is 0. So I get that is 0, 0. Okay. So when I'm given that x is 0, I also know that, excuse me, that y is 0. Man, your boy's struggling over here. All right, here we go. Last but not least, I'm going to change this color to blue here. Now it's not giving us x. It's giving us y. Okay, so when I have this y, it says y equals -1. Instead of taking the x out and putting in -1, well, that wouldn't make sense because it's not giving me x. It's giving me y. So essentially it's saying, hey, we have this ordered pair. I'm telling you the y value is -1. Can you tell me the x value? We can certainly do that. Now, instead of solving for y, we're going to solve for x. So let's use this same equation, and I'm going to take y out and put in a -1. So I get x plus 4. I'm going to put this -1 in for y equals 0. A little bit of math to do here. 4 times -1 is -4. So I get x minus 4 equals 0. Well, to move a -4, inverse of that is adding. These disappear. I get x equals 4. So what does that mean? That means that the solution would be 4 comma -1. I took the information that was given. It gave me the y. It asked me to find the ordered pair solution. It already told me half. I found the other half. That solution is 4, -1. That point would fall on that line. Let's keep moving. It says if we are not given specific values for x and y, like we were up here, right? This one says, well, x is going to be -4, and x is going to be 0, and y is going to be -1. So what if we're not given that, right? There's situations where it does not give us that. It says if we are not given specific values for x and y, we can generate our own. Let's move this here, maybe. It says all we need to do is organize a table and pick a couple convenient values. Okay, so it says generate a table of values for the following equation. So here's our equation. X minus 2y equals 4. Okay, I've already put these in here for us. It is nice when we're generating a table to pick numbers that are easy and convenient for us. What does easy mean, right? Easy means small numbers, right? It's nice to avoid decimals if we can. And I picked a couple of negative values here because when I'm graphing, the negative is that left side. It really allows me to see the left side of the table, the graph. 0 is nice, especially when we have a problem. Like, for example, our coffee problem, right? At 0 trips, how much money did she have on the gift card to the cafe? It's just nice to be able to check our zeros. And then again, a couple small numbers, but positive. Sometimes we have more data on the negative side or more data on the positive side. So here's our 5 values. We're going to plug them in one at a time, right? And see if we can generate some Y values for some ordered pairs that would lead us to essentially and eventually a graph. Okay, so we're going to use this x minus 2y equals 4. And these are a list of our x values. Okay, so what that means is we're going to plug those in one at a time for x. If I plug in 5 different x values, I should be getting 5 different y values over here. So the first one on our list is this guy right here, -2. Let's plug it in. It's going in for x. So I have here on this first one, -2. I'm putting it in for this x value, minus 2y equals 4. Okay, a couple of steps to get me y by itself. I should probably add 2. I get -2y equals 6. The opposite of multiplying by -2 is dividing by -2. So I'm going to divide by -2, and I get y equals -3. Well, there's my first value, right? -3. I'm going to plug that in. All right, switch up to color here. Let's go with a nice, solid green. Okay, this one, next value, I'm going to plug in this -1. Okay, I'm going to plug it in for x again. It's on my x list. Let's go ahead and do it. Instead of x minus 2y, I'm going to have -1 minus 2y equals 4. The inverse of subtracting 1 is adding 1. I get -2y equals, well, 4 plus 1 is 5. Also got to divide by -2 because I'm solving for y, and I get y equals 5 over -2. I can leave it like that. 5 divided by -2 also is -2.5. Since I'm not using this as like a slope or a rise over run, not a bad idea to get a decimal in there if you find that convenient as well. What's my next value? Let's switch up the color again here. Let's rock a red. Okay, my next value is red. My next x value it gave us is a 0, or that we chose, is a 0, right? So let's go ahead and plug 0 in for x, right? So I'm just going to go ahead and do this over here. I get that instead of x minus 2y, I'm doing 0 minus 2y equals 4. 0 really means nothing. I guess you could minus 0 on both sides, right? Gone. 4 minus 0 is still 4. I get -2y. I can divide by -2, divide by -2, and I get that y equals -2. So when I plugged a 0 in for x, it produced a -2 for y. 2 more. We got some nice colors here that we can use. Let's see if we can go 5 colors. Let's rock this purple. My next value for x that we chose was that +1, nice and small and positive. Let's go ahead and put this in here. So now I have 1 minus 2y equals 4. This is +1. How do I get rid of a +1? I subtract 1. -1. 1 minus 1 is gone. -2y equals 4 minus 1 is 3. Divide by -2. Divide by -2. -2 divided by -2 is 1. So I have 1y equals 3 divided by -2 is a fraction. It's not going to give us a nice whole integer, but I know that that's -1.5. So our fourth solution on this would be when I plugged in a 1, I got -1.5. And last but not least, what color do we got here? Let's rock a nice, beautiful, let's go gold. We're going to rock this gold. Let's rock this gold. Here we go. I see that we're going to plug a +2 in right here. Here's our +2. So now I have 2 minus 2y equals 4. -2 because that's positive. I got to get rid of it. 2 minus 2 is nothing. That's great. -2y equals 4 minus 2 is 2. Divided by -2. Divided by -2. I get y equals 2 divided by -2 is -1. So when I plug in a 2, I get out a -1. That's another solution for me. What we just found is 5 ordered pairs, right? This would be on the graph. So would this. So would this. So would this. And so would this. And there's many more. We just chose 5 inputs. Again, we chose the numbers -2, -1, 0, 1, and 2. Small, couple negatives, couple positives, a 0. They're great pieces to check. All right, here we go. So let's take a look at this last example. This example here has a new equation for us, right? So this is y equals 1/2 x minus 3. I notice I have 1/2 times x. So conveniently thinking, I know those are multiplying, and I'm multiplying by 1/2. If I want to try to avoid decimals and fractions, which is nice, let's choose numbers that we know when we multiply by 1/2 will give us a nice integer value. Okay, so those to me, right, are my even values, right? When I cut an even number in half, I get a nice even number. When I cut an odd number in half, I'm going to get a decimal or a fraction. So small is still good, but instead of -2 and -1, let's go -4 and -2. I like the 0. And then let's go +2 and +4. Still small, still a couple negatives, still a couple positives, and still that nice, lovely 0. Okay, we're going to go ahead and plug these in one at a time and see if we can produce 5 solutions to this equation here. Okay, so let's plug in that x value in. Let's go ahead and rock back to our, let's go red here again. All right, so I'm going to plug in -4 first. I get y equals -4 times a half minus 3. So what do we got here? So calculator and or brain tells me that -4 times a half is -2 minus 3. Well, -2 minus 3 is -5. So my first ordered pair, or my first set of solutions, or my first solution is -4, -5. Moving on, let's go ahead and go back. Let's follow the order from earlier. Let's go with the blue. The next value I'm plugging in is -2 right here. Whoops, that's not blue, that's purple. Let's switch that back. There we go. So let's plug in -2. So I get y equals -4. Oh, I completely just made that last one up. No, I didn't. That's right. I didn't write them in the right order. Let's fix that. 1/2 times -2 minus 3. Well, what's 1/2 of -2? That's -1. And -1 minus 3 is -4. So let's plug in a -4 here. All right, let's keep moving. So next solution we're going to try to solve for, we chose that x was going to be 0, right? I see that right here. Let's go ahead and get this out of the way. Come on. I got that right there. Oh, this is not switching to that green. I want that green. I want that green. Here we go. All right, we're back. So is this number? Let's plug in the 0. So I get y. I'm going to make a little bit of space. Y equals 1/2 times 0 minus 3. Well, 0 times anything is 0, and 0 minus 3 is -3. So now that my next value is -3. All right, let's keep moving. My next value, what did I choose here? I chose purple. Let's see if I can get a little bit better there. Nice, okay. My next value here is this 2. Positive 2 this time. So now I get y equals 1/2 times 2 minus 3. 1/2 of 2 is 1. Minus 3. Well, 1 minus 3 is -2. So my next value is -2. And last but not least, we're going to go back to this nice pretty gold here, and we're going to plug in this value of 4 to find our last solution set. So I have y equals 1/2 of 4 minus 4. 1/2 of 4 is 2, and 2 minus 4 is -2. Ooh, did I do something wrong? -2. 4. 1/2 of 4 is 2. 2 minus 4 is -2. 1/2 of 2 is 1. Oh, this is a 3. This is a 3. Let's go ahead and fix that. Mr. Neal, what are we doing? We almost made it through the whole entire notes. This should be a 3. So let's go back there. This is a 3. This is a 3. 2 minus 3 is -1. Whew. Nice catch there. Lovely catch. Okay. To summarize, we found solutions. Sometimes we were given the equation itself, and we were asked up above, we were asked here, can you check and verify and see if that actually is a solution? And we plugged those values in. Sometimes we were given just half, right? They said, hey, here's the x value, find the y value, or vice versa. Here's the y value, find the x value. And last but not least, we were just given just simply an equation, and they gave us the freedom to go ahead and pick values ourselves. It asked us to generate a table of values for the following equations. We just found 5 solutions here, and up above, we found 5 solutions there as well. We like to pick small, convenient numbers, paying attention to, do we have things like fractions or decimals where we can, excuse me, where we can avoid some of those as well. Thank you for hopping in, and we'll see you in lesson 10.